Welcome, y'all. Back to some more geometry. Today we're talking about doing proofs with triangles. Now, we're going to talk two ways to prove triangles are true. SSS, standing for side, and SAS, side, angle, side. Now, these next two lessons, 4.4 and 4.5, they will be very similar. We're proving triangles, but using this. We're going to go over these theorems first. So the first one is this postulate side. It says that if I can show three sides of one triangle are congruent to three sides of another triangle, then the triangles themselves are congruent. Right here, we said that AB, side AB is congruent to side DE, BC is the EF, and AC is the DF. So if we show that three sides are congruent, then these triangles are congruent for sure. Say triangle ABC is congruent to triangle DEF. The way you label this is very matters as well, because since all the sides are congruent, then by CPCTC, we could say that the angles are congruent to each other as well. So it's very important that we're very specific of saying the order we say this right here. So for example, this reflective property is something you will use a lot. So let's say you have these two triangles right here. They're facing each other and they're touching down the middle. And they tell you that HI right here is congruent to JI and HG is congruent to JG. Well, we're missing one more side. Well, the side they touch, they both share that side. So that'd be what we call reflective property. We're saying that the same side on this side of the triangle is congruent to the same side on this side. So now that we have all three sides, side HI, IG, and GH congruent to JI, IG, and GH. Even though they share that IG, it's the same side, they still goes to both triangles. So we'll say triangle HIG is congruent to triangle. What will be the order over here, y'all? Yeah, JIG. Very important the way you say these right here. So that's the first postulate we're talking about, the side congruency right here. Let's look at the next one. On the next one, we're talking about side, angle, side. So what do you think that means? We need a side, then an angle, then the side. Now, the order this is said is very important because you'll have the side, then followed by the angle after that, and then the side that comes to that. So it says two sides and the included angle, meaning the angle in between those two sides, of one triangle are congruent to the two sides of the other one and an angle. So looking at this problem right here, which angles for sure, looking at just the problem without even knowing any other information, what is for sure congruent here? That'll be these two angles right here in the middle. These are for sure congruent regardless of the triangles are congruent or not. The two angles are congruent to each other because they're vertical angles. So they're vertical angles. So vertical angles are always congruent. So those are congruent. So according to this theorem, we got the angle. I mean, we need to show somehow that the two sides right next to each other, the angle, so this angle right here, this side right here, and this side right here, are congruent to the two other sides on the other side of the angles right here. So in this case, if we can show that NO is congruent to PO and MO is congruent to QO, and then knowing the angle NOM is congruent to POQ by vertical angles, then we can say the triangle NOM is congruent to triangle POQ right here by the side angle side postulate. Now, just like we talked about in the last lesson, we are very specific about this. Once you show that the two angles are congruent, then every other part of one triangle is congruent to every other part of the other one by CP, CTC, or corresponding parts of congruent triangles are congruent. So now that we said that these two triangles are congruent, we can then go through and say, hey, angle N is congruent to angle P by CPCTC, and angle M is congruent to angle Q by CPCTC. And of course, this third side, PQ, is congruent to MN by CPCTC. Let's kind of do an example of what you'll see, something like that. So we'll start with this. We always are given the first spot. So they're telling us MN is congruent to PN. And of course, you could write two things on the same line. LM is congruent to LP. So let's go through and mark that. So they're saying, hey, LMN is congruent to PN, okay? and LM is congruent to LP right here. All right, so we have that. Now, the next step will be, so either we're looking for another side or an angle. So just looking at the picture, it's kind of obvious. We're looking for a side right here. But let's look at the proof right here. It's half of this. We're looking for some sort of reflective property right here. So reflective property happens when two sides touch each other. So in this case, LN is congruent to LN. It's congruent to itself, LN. So now I have 1, 2, 3 sides, 1, 2, 3 sides. I have 3 sides congruent to each other. So I can say the triangles are congruent. So triangle L, L, and M is congruent to triangle L and P by side, side, side. But that's not the final step. The final step is asking us how these two angles congruent. So LMN, this angle right here, is that congruent to LPN? Yes. Why, y'all? Why? Well, what we just talked about earlier. Corresponding parts of congruent triangles are congruent. This is very important. This can only be used once this step happens. Once the triangles are shown to be congruent, then we can say this for any other part of the axis. So as you do the proof packet that you'll get later, you can only say this after this. Hopefully that helps y'all. I'll see you guys later. Bye.